Okay. Oh, sorry. Did not mean to do that. So for this one, this is the module 7, and it's chapter 15, question 10. So I'm going to read it out loud and then explain my answers. In 1960, census results indicated that the age at which American men first married had a mean of 23.3 years. It is widely suspected that young people today are waiting longer to get married. We want to find out if the mean age of first marriage has increased since then. So, for part A, we're going to write an appropriate hypothesis. I wrote the H naught, or the null hypothesis, is that the mean is less than or equal to 23.3, since it wants to know. So for the alternative, which is what it wants to know if the mean age for the marriage has increased since then. So it doesn't want to know anything below 23.3. It actually just wants to know everything above 23.3. So our alternative is going to be the mean is greater than 23.3. So part B. We plan to test our hypothesis by selecting a random sample of 40 men who married for the first time last year. Do you think the necessary assumption for inference are satisfied? Explain. So for B, I said yes. As we know, we can use the success-failure rate, meaning there has to be at least 10 successes, at least 10 failures, and if you see, we have 40. So there's at least 10 successes, which would be less than or equal to 23.3 years, or failures being higher than 23.3 years. So I said 40 is higher than 10, so there is at least 10 successes and 10 failures, and that is a way to indicate if the distribution is normal and if the assumptions are satisfied. So for C, describe the appropriate sampling distribution model for the mean age in each samples. For C, I said T distribution modeling for mean ages of men who are getting married. And then D, the men in our sample married at an average age of 24.2 years with a standard deviation of 5.3 years that results in a t-statistic of 1.074. What is the p-value for this? So, how I got my p-value? Actually, I watched this in one of the videos. I took my t-statistic of 1.074, and then I went to a t-table, went to the z, the closest to it, which would be right here, and then I went out. And then that's how I got my number up here. So, for us, we got a value of 0.15, which is right here. Because we just want the area in one tail. If we wanted the area in both tails, we would use right here. And if we wanted the area below, right here. But since we just want the area in one tail, we're just going to get 0.15 for our p-value. Okay, so going back to this. For E, explain in context what this p-value means. For E, it is the probability that we get a mean above the original mean in the null hypothesis without wrongly rejecting it. So basically, in other words, this is the kind of how we say if we get a mean above the null hypothesis, it's the percent of us not wrongly rejecting it. So let me explain, or I guess I think I explained it again here. The chances of incorrectly rejecting a null hypothesis is higher than our significance level, which means we are unable to correctly reject the null. So let me just go through my conclusion. So I said I'm going to retain the null hypothesis. The men who got married for the first time, mean age is higher than 23.3 and below years old. I can say they are approximately 24.2 years old based on my conclusion. I also said this kind of to sum it up without using any of these terms. I said the chances of incorrectly rejecting the null hypothesis is higher than our significance level, which means we are unable to correctly reject the null, meaning our p-value is higher than our significance threshold of 0.05. So in that case, right here, it means we are unable to correctly reject the null, meaning we are going to retain the null hypothesis. I watched all of the videos that the professor gave us, and that is how I got all of my answers. Please let me know if you have any other questions. Thank you.